Good afternoon, everybody. My name is David Godwin, and I'm the director of the Southern Fire Exchange with the University of Florida. And I'm joined today by Marynell Armstrong, who was with our Southern Fire Exchange team through Tall Timbers Research Station. Today, I have a presentation by Mr. Brett Lawrence from Raven Environmental. And Brett will be talking about using drones for prescribed fire ignitions in the Southeast. So, with all that out of the way, it's my pleasure to introduce our speaker today. Mr. Brett Lawrence is a wildlife biologist and GIS specialist with Raven Environmental in East Texas. Mr. Lawrence received his Bachelor of Science in Biology from Sam Houston University and his Master's of Geoscience in Geographic Information, Science and Technology from Texas A&M University. Brett has over 10 years of experience working in natural resources and environmental compliance in the regions of Southeast Texas and Central Louisiana. During this time, he has participated in projects ranging from red-cockaded woodpecker nest monitoring, herpetological and avian population monitoring, wildlife habitat restoration, and sustainable forestry. Brett also plays a significant role in Raven Environmental's prescribed fire operations, the UAS-based remote sensing program that they have, and also geospatial data management and analysis. So welcome, Brett. I'm excited to see your presentation, and we have over 190 folks on the line today, so I know we're all looking forward to hearing what you have to say and asking some questions afterwards. So 1 second, everybody, as we trade out slides and let Brett get started. Thanks.
Okay, well, thanks again, David, for giving me the opportunity to come and talk a little bit about our experience with UAS aerial ignition. The title of today's presentation is the impact of UAS aerial ignition on prescribed fire. And as I'm going through the slideshow, I've included a lot of pictures during our time using UAS aerial ignition, just pictures, most of them aerial photographs of burns. And I've also tried to include a little bit of information somewhere in that picture about where the burn was, what kind of ecosystem it was, and how large the unit size was. Quick overview of what I'm going to talk about today. I'll provide a little background on Raven's burn program, just so we can have some context about what it is we do. Then I'll introduce the UAS and the equipment we use when we burn with our UAS system. And I've done some analysis comparing both UAS and non-UAS burning, and I'll share some insights into how those two things compare in our experience. Excuse me. And then I also want to share a lot of kind of programmatic perspectives, just operationally, how the UAS, what it's looked like in the 4 years we've been using it. And then finally, I've got a number of slides about how the UAS has impacted our fire program, and I've also provided some case studies to kind of provide a little evidence to back that up. So yeah, so our burning primarily is done in both Louisiana and Texas over a pretty significant scale. We burn a lot of different, or regional scale, we burn a lot of different places in Texas and central and west Louisiana and the longleaf pine in that state. We burn frequently where wildland urban interface is a consideration, namely in Montgomery County, which is just north of Houston. We do quite a bit of burning there. And if anyone's familiar with Montgomery County, they know there's been a tremendous amount of urban growth. And so wildland urban interface is a big consideration there. Our burning is almost always for forested understory or native grassland restoration. We almost never do any site prep burning, except very recently we did a couple site prep burns with the drone. We burn during any time of year. You know, it's pretty warm down here in Southeast Texas, so we can get plenty of winter season burns done here. In fact, January and February are probably the months we do quite a bit of our burning every year. Again, kind of providing some context, we definitely work with resources and personnel that's smaller than, a government agency like Forest Service, for example. And UAS burns, we've been using the UAS for our burning since very late 2018. In fact, we purchased our first system in November of 2018. So the equipment we use when we burn with the UAS is comprised mainly of these two components, and we have two systems. The first, of course, is the UAV itself, which is a DJI Matrice 600 Pro, a fairly large hexacopter drone. It's capable of about 40 minutes of flight time with no payload, or 18 minutes of flight time with a full payload. Of course, you're losing ignition spheres and payload as you're flying. So on average, I think our flight time is probably somewhere around 30 minutes as you're igniting. And then the other major component is, of course, the Ignis unit, which was developed by Drone Amplified in Lincoln, Nebraska. And that's, of course, the picture on the right here. The Ignis is mostly the hopper portion, which is the upper part of the Ignis, and it can hold about 450 dragon egg ignition spheres. You'll notice on the left side of the hopper is the antifreeze reservoir. We use full strength antifreeze. And then that milled aluminum portion on the very bottom of the Ignis is the dropper portion, where the spheres are injected and then dropped before they ignite on the ground. Some other additional equipment we use, we of course have M600 batteries. We carry 6 total sets. One set is comprised of 6 batteries, so 36 batteries total. Ignis batteries, flight controller, a tablet, USB-C cable, and then again, ethylene glycol or full strength antifreeze, and dragon egg ignition spheres. This system does not use the Primo ignition spheres. When we initially started burning, we started with 3 and then eventually 4 sets of batteries. And we found that generally that would meet the demands of your average burn day. And this is M600 batteries, which is kind of the crucial one, and that's usually the limiting factor as far as batteries go. But an issue we would run into during the summer and during very hot burns is the batteries are a little prone to overheating. So when you come down from a flight, they're blinking at you, giving the status of that they've overheated. And it would take somewhere around 15 minutes, maybe even 20 minutes to get them to a point where you could put them back on the charger and charge the batteries again. Because that was creating some issues, we added 2 more sets, and we found that 6 sets and also having a generator with us when we burn almost always meets our battery demands for pretty much any burn day. And then lastly, we move all of our drone equipment around in a Nissan Xterra, which you of course can see in this picture. That's been my preferred model. I can stuff everything in the Xterra, and it's of course a very kind of nimble, good vehicle for getting down fire lanes and hard to access areas. So that system has worked really well for us. Okay, so on this slide, I'm kind of transitioning into some of that analysis I spoke of, comparing UAS and non-UAS burns. We took a sampling of, well, really all of our burning between 2019 and 2021, which is where most of our UAS burns have occurred in that time frame, and compared them. And first and foremost, we found in terms of efficiency, we were burning 122% more, or 151 more acres on per day on average. However, we almost always have about 1 extra person on those burns. And that's almost definitely accounting for mainly myself, the pilot in command. And, sometimes we have a designated visual observer, not just someone on our staff helping me with that. And so while we do see that jump in acreage, we also have about a 27% staffing increase when we burn with the UAS. And then in terms of time efficiency, Went through our flight logs and, compared the amount of acres to how much flight time. And we can burn on average about 247 acres in just over an hour. And that's just the interior ignition phase of the burn using the UAS. So we did have some additional data to kind of do some interesting analysis. We conduct post-burn assessments using the FMH protocols on a client who we've done a lot of management for in the last 20 years, called Cooks Branch Conservancy in Montgomery County, Texas. So all of this burning is the same fuel model in the same place. While it's not a large sampling, we still had, a reasonable amount of burns, both UAS and non-UAS, to compare. And what we found was essentially UAS burns resulted in slightly less severe fire effects, particularly vegetation and substrate burn severity metrics were a little lower when you compare the two groups, and also crown scorch percentage and char height. Conversely, we didn't find a significant difference between the percentage of the unit that was unburned and also scorch height. So the way I interpreted that was a UAS burn, while a little less severe in terms of fire effects, it was generating a satisfactory result. And I can speak for, our clients' feedback and just our observations is that UAS burns almost always had, again, satisfactory results. So the next 4 or 5 slides are just, kind of a programmatic perspective, and just some slides about, operationally what the UAS looked like day to day. Total, we burned just over 15,000 acres on 58 UAS burns between 2019 and 2021. And we, the first year of operation, so most of 2019, we used the first version of the Ignis 1.0. And then, on November 19th, we acquired a Ignis 2.0, which was a huge improvement. And of course, now we have 2 of those. But doing some analysis of, these numbers kind of on this programmatic scale, what I discovered was when you just look at non-UAS burning for the last 10 years, which is illustrated in this table or graph on the right, it was very difficult, and there was a high correlation basically between the amount of acres we burned each year and the amount of days we burned each year. Almost a perfect correlation. So if we burned less acres, it's because we burned, less days. And if we burned quite a few more acres, we obviously burned more days. However, once we introduced the UAS, the drone, we were able to disrupt that trend in a pretty significant way. And really there wasn't any other example of, something we're incorporating our burn program that did that prior to its incorporation. One of the questions I always get about the drone is cost. So I thought it was important to include some details in that regard. Again, we have 2 systems. The first is about 4 years old. Again, we purchased in November of 2018 for just over $40,000. And then the second we bought around 2 years ago. We use a Zenmuse XT2 camera, so the dual thermal, which is a pretty expensive sensor. And so that system cost is about just over $50,000, a little more. It's however worth mentioning that the DJI Matrice 600 Pro has been discontinued recently by DJI. And I know also some of the feds and government agencies had trouble using and acquiring the Chinese-made products. So Drone Amplified has now paired the Ignis with a newer Alta X system or drone that's manufactured here in the US. And while I don't have specific numbers, it's my understanding that that new system cost is around $75,000. From 2019 to 2021, we used just under 50,000 spheres total, so Dragonite spheres. And after, again, going through our flight logs and calculating some things, I discovered that we used about just over 3 spheres per acre. So that's averaging for all of our UAS burning. And then I took our costs, what we pay for those spheres, and calculated that we spend just over $1 an acre in sphere costs. And so if you translate that to the cost of spheres for our average unit size during that period, if we did a UAS burn, we spent just over $300 on ignition spheres. Use a little water. Maintenance is also a question that I get asked. Additionally, people seem to have an interest in if you've crashed the drone or if you've had major accidents. All the maintenance and almost all the repairs and certainly inspections were performed by myself here at Raven. There was a couple occasions where we sent our system to Drone Amplify. They did some larger repairs for us. Namely, we had some motor mount reinforcements installed in our older system because there were some incidents where I think after a couple of years of operation, the M600 motor mount or motor housings were failing, and the prop would come off. And of course, it's my understanding it would be a total failure. The drone would basically fall out of the sky. So as a preventative measure, we had those installed for about $700. As far as accidents go, during our operations, there was 2, both of which weren't too significant. On one instance, during takeoff, it was just an operator error problem. The drone tipped over and broke some props, and we were actually able to fix it in the field and continue operating. And then on the other occasion, it's actually my fault. I installed a prop with the wrong directionality. So each prop arm has certain directionality. So when I did that and I tried to take off the next time, the drone just, it didn't respond normally at all. And again, just kind of tipped over and broke a prop housing. So I discovered it's much easier to just replace an entire prop arm. And that cost us about $325. We've replaced all the props on our older unit for about $360. And we did have one major hardware failure on our older Ignis unit. So after 28 hours of operation, which that unit has about 41 hours total on it so far, the corkscrew that feeds ignition spheres into the dropper portion of the Ignis, there's a bearing on one side of it that failed. And fortunately, we were in the Austin, Texas area, which has plenty of stores available. There was a specialist hobby store was able to get that bearing. I fixed it later that evening, and we continued flying the next day. A little more on maintenance, especially with batteries. We've replaced 2 Ignis batteries, the oldest ones we had with the first system. They actually were still functional and still holding a charge, and there really wasn't, I didn't have to replace them, but they were beginning to swell some. So I thought it was probably a good idea to go and replace those. But probably even more significant, the M600 batteries, I've kind of kept my eye on because the DJI Tree 600 Pro has been discontinued again. They don't manufacture it anymore. At the moment, it doesn't look like a problem, but I've had some concerns of whether batteries might be hard to acquire later on. So we did some diagnostic tests on our 3 oldest sets, 6 total, and discovered that of those 3 sets, they've all been discharged about 60 times. And the remaining battery life for all 3 sets is somewhere around 86%, which I think is pretty good. We've really made a lot of effort to take care of our batteries and discharge and charge them as a set. And so I think things are looking pretty good in that area. All right. So basically the remainder of my slides are just going to talk about how the drone has changed our burning, how it's impacted our prescribed fire program. And I'll share in my experience using the drone and also kind of getting thoughts from burn managers that I work with here at Raven and some of our land management agencies in Texas. I'll share some of what I think are relevant points about how it's impacted our fire program. The first and probably for me the biggest impact it had, again, we're a relatively small, burn vendor. Well, we generally work with a relatively small crew, so our ability to do all of our interior ignition with the UAS and then reallocate those people to patrolling and watching lines and, for example, responding to like a spot out. That was a tremendous change and a really positive one. I think you can make a strong argument that definitely results in both a safer burn for our staff, keeping them out of the woods, and also for surrounding communities. Because you have so many various app capabilities, I think there's a big argument that when we were burning, we had a much greater awareness. For example, me being a GIS person, I basically have a complete latitude to prepare a map with anything that has a spatial component. I can add to our map that we use while we're flying. And so this top left image is basically a screenshot of what I'm looking at during a burn. And you can see I've added some various features to this map. The green crosses are potential launch sites. The blue dashed line is a 100-foot buffer within the burn unit's boundaries. In my experience, burn unit shape files can be a bit old and antiquated, and maybe the line isn't correct. So I like to buffer inside and give myself a little space so I don't potentially put any spheres over a fire line. And also in this case, the red circular buffers, which have been dissolved together, is about a 500-meter buffer. This was a heavily forested area. So to maintain visual line of sight of the drone, I was having to do a lot of moving around. So those buffers help me basically understand where and how far I can get potentially prior to ever even being on the burn unit. So that awareness is, that heightened awareness, I think you can make an argument is there before you even arrive. But then additionally, during the burn, you can use a protective geofinch, which is the white line. And so in the event you inadvertently cross that line while you're igniting, the drone automatically stops. You can see I've put that within that buffer too while I was operating. So that helps tremendously. And then finally, there's the video feed, which gives you, a great aerial perspective of what's going on, not just where you're igniting, but you might be igniting and also doing a little reconnaissance work as you're coming and going, for example, keeping an eye out for something going on the line that maybe people on the ground aren't aware of. And I've included this picture in the bottom left because it illustrates that with the dual thermal camera, you can also have even more awareness because you can see through, in this example, a smoke column. Building on that kind of awareness, some other app features that you can employ are the mission planning features. And you can essentially, there's a lot of ability to change parameters and mission plan. For example, you can designate your transect spacing, also your sphere spacing. You can change the orientation of your transects, and someone piloting the drone has the option to fly their mission fully automated. Don't ask me why, but in my experience, I've always flown manually, and it's just how I operate all the time. It's just what I'm comfortable with. I still use these features. However, usually my system is I set up a grid. Depending on fire behavior and the fuel model, I'll find a correct transect spacing and also sphere spacing. And then I basically fly those transects. So I'm not flying them automated, but I'm using them as a reference. And of course, as fire behavior is changing, you have the capability at any moment to change any of those parameters and adjust and adapt to what the fire behavior is doing. Okay, so here I'm going to transition into kind of a more some big discussion points that I think are relevant and worth considering in ways that the UAS has had an impact. And for each point, I'll provide a case study of specific burn that was our experience. So first and foremost, you know, with climate change, there's definitely strong evidence that we're losing burn days that fall in prescription where there's the appropriate weather, but also there's this lengthening summer fire season with more volatile fire behavior. So you really have to take advantage of those limited days as much as possible. So one way that the drone has helped us with that is by basically enabling us to burn unit sizes that we previously could not. I will preface that with these opportunities don't present themselves very frequently. You know, we have, you know, a limited amount of staff. We can only, you know, manage such so many acres. Additionally, you know, smoke management is always a very important consideration. And here in Texas, you just don't find a lot of opportunities to burn, for example, 1,000 acres where you aren't impacting someone or sensitive smoke receptors in some way. So when those rare opportunities do present themselves, we can essentially take advantage of more acres and, again, those limited number of days that are available. And so in this case study in Brown County, Texas, we burned, this is the largest burn we've done with the UAS, and I think it was a crew of about 10 people. We burned just over 1,000 acres. Prior to that, in the last 10 years, with non-UAS burning, the largest unit size we've ever done was around 450 acres. So wildland-urban interface, of course, is a huge consideration for anyone working in the fire community and conducting prescribed fire operations. I read somewhere recently that your best window for atmospheric lift is before 4 p.m. on aerial ignition burns. And so the UAS really enables us to get that smoke up and out in a way we couldn't previously because we can cover ground so quickly. And that helps with that wildland-urban interface problem. So a case study that I think is relevant to this point. We were burning in Huntsville State Park. I was actually burning with Texas Parks and Wildlife, and we had a very small amount of sort of a mist, certainly not rain, but more of a mist around like I think 1 p.m. when they were putting their backing fire in, and it really, you know, the RHs jumped. We had to stop lighting temporarily. We kind of reconvened and discussed if the burn was still even possible, if it was worth continuing. It was really just this very small cell that popped up above us for very temporarily and then moved out immediately. And in this situation, we were able to wait about an hour, let things, you know, let this small cell again clear out, let things dry a little bit, and eventually we were able to get our backing fire going again. And again, because the UAS can move so quickly, between 2:30 and 4, we lit just over 300 acres, and we're again able to get that smoke up and out within that appropriate window. So again, that helps with wildland urban interface. In this case, it helped us reach our goals in a situation where I think without the UAS, that would have been very difficult to impossible. The UAS, I think you can make a strong argument, increases safety, mainly in the form of, I spoke of that reallocation of people away from interior igniting, dragging a torch through potentially unforgiving understory and difficult environments, and it keeps them on the line. So a good case study for that. We had a pretty sizable burn in Montgomery County, Texas. It had a pretty high fuel load. You can tell from the image that the smoke is a bit dark and a bit ominous. So the fire behavior was pretty strong that day. We certainly were in prescription, but between the high fuel load and just the way the fire behavior was acting that day was, some pretty intense fire behavior. So, and this is a bit redundant, but keeping those people out of that unforgiving environment, that thick understory, it removes those hazards, tripping, falling hazards, the difficulty of navigating in those types of environments. And additionally, they're on the lines, they're helping us monitor maybe some difficult fire behavior, and I think that helps with safety tremendously. And then finally, an impact that we've observed is our ability to better satisfy our fuel management conservation goals. We do a lot of burning for habitat improvement, particularly red cockaded woodpecker habitat. Our increases in efficiency and safety, they've helped us reach our goals much easier. And rather than include some specific case studies, I just kind of had some scenarios that I've experienced and wanted to share. The first being, for example, if we're burning and fire behavior is a bit excessive, we do a lot of understory burning. So, of course, your goal is to protect the overstory. You certainly don't want mortality, but you want to try to reduce the amount of stress you put on the overstory too, in a lot of situations. And we've been able to mission plan and strategize in such a way that we can avoid those situations. So an example might be in Louisiana, where we can night burn. If that critical mid-afternoon window is proving to be some pretty hot burning, we might wait a little longer into late afternoon or even evening, knowing that we can cover ground very quickly with the drone, and maybe wait till the fire behavior is calmed down a little bit. Scenario two is one that I've encountered quite a bit. Essentially, you get out to a burn. When you start igniting the first part of the day, maybe the fire behavior is actually kind of on the other end. It's a little marginal in terms of it's not burning great. So of course, on the other end of the spectrum, you don't want to preferably leave things unburned. So usually the way this situation manifests itself is we'll complete the burn, and a large percentage of it is burned. But one way really helpful way that drone is one way we've been able to employ it is basically getting over the unit and targeting, because you have that great perspective from up there, you can find those unburned areas and you can target them very precisely. You can locate them, ignite them, and fill in some of those unburned areas. And then scenario three, there's situations sometimes you have unburned areas downwind of, burned areas downwind of your unit you're planning on. That's something that doesn't happen or does happen somewhat regularly. And so with the UAS, what we found is if you're in a favorable situation like that where you can cover ground really quickly, we can basically arrive get things started and get the unit burned fast enough that we can then mobilize somewhere else. And typically the way that helps us is it makes us enables us to make preparations for maybe the following day. I think it's very rare, if ever, that we've been able to say burn a unit over here so quickly that we can move over and burn something. I don't find that that's practical. I think we've tried that and it hasn't been very effective. But what it does do is we can complete our burning much faster than we would without the UAS. And then again, make some preparations for more burning that week, or maybe we see some fire weather the following week. We have that time with the UAS that we didn't before. All right, so while there are a lot of benefits to using the UAS, increase efficiency and safety and those kinds of things in our experience, we do still have, of course, some limiting factors. Namely, at the FAA line of sight rule is it makes some units impossible. There's just not an option, particularly heavily forested areas and like East Texas and the Piney Woods, for example. If there's not a good launch site, even in like a prairie area that's not necessarily right next to, but in close proximity, it's very difficult to impossible to observe the drone the entire time. Also, hopper capacity and battery requirements can come into play in some cases, especially if you're doing a very large burn, which again, those 1,000-acre burns are very rare for us. But there's a lot of landing, refilling the hopper, which you can do quickly, but it's certainly a limiting factor at times. One scenario that I've found is a little difficult is if you're launching from, if your best launch site is like a little disjunct from the unit itself, and you're doing a lot of flying in and out, particularly if you're flying back to your launch site into like a headwind, you really have to plan carefully with your batteries, because you don't want to push the envelope while you're igniting and then be flying into a headwind, watching your battery depleting as you're trying to land. And then kind of early on when we were operating, we had a handful of issues with range limitations. Again, in the heavily forested areas, that's more difficult on average. But we found ways to manage that better. To be honest, we just, our limit is 400 feet for our altitude, and we just push that every time we fly, because that just enables our range. But sometimes you do find that your range is limited if there's not much topography to work with, and if there's a pretty forested landscape. All right, so in conclusion, in our case study, we found that the UAS represented, an increased efficiency, but it did require more staffing, training, and of course costs. Another big point, the fire effects on our UAS burns were, while a little less severe, they were satisfactory, and we were meeting our goals in terms of fire effects. And our argument is that the UAS has had a positive impact on our ability to meet fuel management and conservation goals, despite what I would describe, especially here in Texas, as an increasingly complex burn environment for those of us that work in this field. And my final closing thought, I was once told by Jamie, a fire management officer here in Texas, that you can either burn more acres in a day or burn more days, which, while kind of simple, I thought was a good way to think about things. And I think if you're going to burn more days, that's going to be difficult as climate change continues to, I read recently that we're in a paper, we're losing something like 1 burn day each year. And of course, again, that summer season is extending. We're we're dedicating a lot of resources to our wildfire season. So I think there's going to be some big challenges in that regard. Conversely, you can earn more acres, but that might be difficult to do to, a comparable standard of fire effects, and also making sure that you keep safety in mind. So in our experience and our argument is that the UAS is a reasonable tool for meeting some of that latter criteria. And it's really the first thing that we've incorporated into our burn program, where we saw a big decorrelation in the amount of acres we're able to burn each year and the amount of days we burn each year. So yeah, that's pretty much it.
Well, Brett, thank you so much for your presentation.
Of course.
Really enjoyed it, and I can already see the questions are starting to have been rolling into the Q&A here in Zoom. So testament to the amount of interest in this particular technology as it applies to prescribed fire management, really across the Southeast and across the country. I think as you and I had talked about earlier, it seems like you're hard pressed to find somebody who's not interested in how these systems intersect with prescribed fire. So I'm going to go through and try and get as many of these questions fielded to you as we can. For those who have questions, please put them in the Q&A tool in Zoom. If you see questions that somebody has already asked, go ahead and click on that little thumbs up, and that'll help us try and prioritize and get to those questions in the time that we have available. Brett, one question I already see that's getting a lot of thumbs up. Dylan's asking about the certifications that the drone pilots have with Raven. He's asking about if they're under Part 107 or do they have to follow along by the NWCG requirements as well. Could you talk about a little bit about that and the kind of training that folks on the team had to go through?
Certainly. So because of course our drone system falls under 55 pounds, it falls within the Part 107 rules and regulations. So first and foremost, obviously myself, and truthfully, this is probably some important context to provide. We are a small company of probably no more than 15 employees at the most at any given time. So in reality, I myself have done the vast majority of our piloting, managing, the growth and development of our program. There's really just been two other people who have piloted the drone on burns. In that time, I trained both of them. They're one of them, when we hired them on, they were already Part 107 certified. The other one I trained, and we got their certification. So that on that end of things are pretty straightforward. However, one of the things we've been working towards for quite a while, and it's been a very lengthy endeavor, is trying to get Part 137 or FAA Part 137 certified, which is basically our certification to carry hazardous materials. And I don't want to take up too much time with this one question, but essentially the FAA, what I can say is not caught up to the innovations that we're seeing. And while they have some regulations to accommodate this use, they're just not sure how to certify folks like us just yet. And I have been working very hard for, not exaggerating, 2 years to figure out what it is they need from me. But they are waiting on guidance from Washington, D.C. because it is such a new technology. So it's been a very slow progress or process that's moved at a snail's pace, and we're still working towards it. I'm working with the FSDO office in North Dakota right now, so it's an ongoing effort.
All right, here's a question in Zoom from Lewis, and Lewis is interested in monitoring the burn beyond ignition. So I think you touched on that a little bit in your presentation, but could you talk about any examples of how y'all have used these for burning either during or post burn monitoring as well?
Certainly, yeah. So during the burn, truthfully, I find that my focus, you've got so much going on when you're igniting, you're keeping an eye on your telemetry data on the app, what's my altitude, how far from myself am I, is my video feed nice and clean and crisp? Just keeping yourself hyper aware of all the things going on around you. I find that like when I'm igniting, and again, because I fly manually too, between all those things going on, I'm not doing a lot of active monitoring outside of igniting, but usually the trip in and the trip out, I definitely am keeping an eye not just on the drone, but anything I'm seeing on the video feed. And if I would say I'm monitoring or providing reconnaissance, it's probably in the form of assessing the fire behavior for the burn manager. I'm usually they're meeting with me, every hour or so throughout the burn day. And I'm telling them, this is what I'm seeing in the unit. Maybe it's some stuff is flaring up really bad and our fire behavior is looking a little excessive. Or maybe I'm seeing like spots that are pretty significant in size that are on burn in that case. And I'm telling them, things are, probably need to dial things up a little bit. I can't say personally that I've ever actually observed, like say a slop over and had to tell the burn boss, hey, over here on the west side of the unit, you've got a situation you need to address, surprisingly, but I don't think it's out of the question at all that could occur at some point where, I see something where a person just hasn't patrolled, say, a line in the last 10 or 15 minutes and, something's happened that I could make, a burn boss aware of.
Here's a question from Ben, and Ben's asking about if you've had issues, with wind, whether it's related to the weather, or I'm thinking thunderstorms in the southeast, or whether it's fire generated wind impacting your ability to control the UAV.
Yep.
A good question.
Yep. No, it is a good question. I'll address the latter part of the question. So as far as, fire behavior, say like a convergence of some fire and creating some kind of micro wind behavior, I've never observed or experienced like the drone doing something erratic in response to something like that. And I bet that's probably because we fly again at that ceiling for our altitude. I just don't know that we're really close enough to the terrestrial surface, to be impacted by those kinds of things. However, I have had the gimbal thrown out of whack, which is pretty scary when that happens. Like the gimbal kind of gives out because there's just too much wind. And initially, when you're observing it on the video feed, it feels like the drone is like going into like a free fall or a tumble. So that was pretty scary the first time that happened. But as far as like the upper end of wind in terms of prescription, I think the upper end is maybe 18 miles per hour. Here in Texas, we had one burn where we started the day in prescription and we had winds gusting just over like 20 miles per hour and maybe even a little higher than that. And I was very, concerned about the possibility of the drone not being able to withstand those types of wind speeds. And did a little research last minute online and looked in some forums about the M600 and people's experience and kind of just went for it. And in that specific case study, the M600 actually did tremendously well. I was really surprised. I never, flying smaller drones, sometimes you get in a big headwind and it's like you can barely get it back. I don't know if anyone's experienced that, but it's kind of scary. The M600 did great. I think that first flight, I kept it real close, but the wind was not impacting the way it was flying very much at all. And I never had any issues flying into that headwind. So it performed really well on those wind speeds.
There's some questions in here about the altitude that you dropped the spears. And I think you touched on that, but maybe you can revisit that. And then could you also talk a little bit about, not really the accuracy, but how much variability is it from where you're planning to drop those spheres from where you're actually seeing those things hit the ground and
Yep.
ignite.
Yeah, so that's something I was very curious about myself. You know, when we were having those range issues early on, we knew that a simple solution was just to fly higher. And initially, part of the reason I flew lower, in fact, my attitude about altitude was let me fly kind of as close to the top of the forested structure as possible, because I was like, my kind of attitude was, you know, if I'm flying and I see some air traffic, I want to be able just kind of be able to get back and stay out of the way. But eventually, when we realized we need to just fly higher, this is a better way to deal with these range challenges. Um, because of my kind of uncertainty and fear of, like, you know, spheres drifting like across a line inadvertently, I did a test of a pretty windy day here at the office just outside, and flew it. You know, I didn't actually ignite the spheres. I didn't inject them. I just dropped them and tried, I think, like 150, 200, 400 feet, and measured. Of course, this is not, you know, like a very exact experiment necessarily. I just want to get an approximation of how much they drifted and how far they fell relative to the drone's position. And it wasn't very significant at all. And I don't remember specifically how much it was, but at like 400 feet, for example, it seemed like they were only falling like 20, 25 feet away from the drone. Again, I don't want to use that number as something people should use. My policy has always been to be very cautious next to lines, especially the downwind side of the unit. If there's not a lot of baseline in, then I'm going to be very trepidatious about approaching it, especially at a high altitude, and dropping near it. And I have had ignition spheres over the line one time, and that was because of a really bad GIS shapefile. I mean, the line was like way off. So fortunately, usually buffering and, you know, keeps that situation at bay.
So that ties into another question we just had in the Q&A about the distance between where, you know, how tight your sphere drops would be. Do you vary that by fuel type and by unit, or do you always use the same density of ignition points?
So the spacing, the sphere spacing, I do vary. However, I don't vary it as much as transect spacing. So usually, if I'm responding to fire behavior or a fuel model that's maybe burning, you know, too intensely or not intense enough, I'll, like, if it's burning like not intense enough, I'll get my transect spacing and I'll close them. Just for reference, generally in forested fuel models, I found that somewhere around like 10 or 15 meter spacing, the actual ignition sphere spacing, has worked well for me. If I get into a like tall grass ecosystem, a native prairie or something, it might be more like 20 or even 25 meter spacing, and then much larger transect spacing, because obviously you've got these great 1 hour fuels that can carry. And so it usually the ignition sphere spacing is somewhere between 15, well, more like 10 to 25 meters. And then there's been a couple times in forested fuel models where maybe fuel conditions are a little marginal. I think there's been a handful of times I got the ignition or the sphere spacing under 10, like even like 6 or 7 meters. I think that's the most narrow I've ever run. And for reference, usually my transect spacing, I think, is somewhere around like 45 to 60 meters.
So, you know, with all this additional equipment on the burn through the UAS systems, we had a question about insurance. Do you have, do you know if the companies had to get additional insurance for the systems themselves, or do you know if you guys have had to explore different liability insurance associated with aerial ignitions?
Yeah, we definitely, so that was actually a pretty big endeavor in and of itself, getting the UAS insured. Both are insured, the drone and Ignis system. And I don't have a lot of the specific details. I have spoke to my boss. His name's Ross Carey. He went through that whole process of working with the underwriter on getting these insured, which, as you can imagine, and anyone in the audience can imagine, was a really weird process. You know, it's pretty odd to approach an insurance company and tell them I want to insure, you know, a drone and an Ignis unit. It drops, you know, ignition spheres. So I think initially their response was, we're not sure if there's any way we can do that. But you know, Ross is a pretty resourceful guy, and again, I don't know how they eventually sorted this out, but they are insured. I know it is very expensive though, at least for a company of our scale. I don't remember what the number is, but it's definitely in the many of thousands of dollars each year for that policy. So.
All right, well, I'm looking at the clock here, and I'm going to go ahead and do one more question from the Q&A. And if you all have additional questions, you can reach out to Brett. We'll have his email address up here in a moment. But Gil has an interesting question in the Q&A, and Gil's saying, you know, with the goal, as they said, is to balance prescribed fires to, you know, to limit wildfires and to support ecological reasons for burning. Do you guys, from how you have applied these systems, do you see that these have helped you with smoke management, in particular in reducing impacts to air quality monitoring stations, and, you know, even in communities, probably more importantly as well?
Yeah, no, I think it has definitely helped us with smoke management. You know, it's included some of that conversation and about wildland urban interface, and how it's something we definitely, you know, an issue we confront regularly. I'm sure most everyone in here that burns confronts regularly. And the biggest way the UAS has helped us in that regard, I can't necessarily speak to specific like air quality monitoring stations, but I can tell you, especially like in Montgomery County, it's definitely a great case study. You know, it hasn't changed the way we plan burns at all. You know, obviously, you know, we don't look at a burn and say, you know, we can burn with a different wind direction now that we can get smoke up and out quickly. We certainly don't have that kind of rationale. It's more like we're definitely going to keep smoke blowing away from these sensitive smoke receptors from these residences. But now, you know, with the uncertainty that's just kind of inherent in fire, I think it helps with that tremendously, because we know when that interior ignition portion of the burn is commencing, we can move really quickly. We can get, you know, that unit lit, we get the smoke up and out in a time frame that is much more comfortable compared to, you know, how we could previously. And then we can begin to manage all those things that might extend into late into the evening, you know, mopping up and, you know, preparations for maybe the following day, or demobilizing, or whatever it is. So.
All right, well, Brett, thank you so much for your presentation today and for your questions. Thanks everybody for your questions. Brett's email address is shared on the screen. So if you'd like to follow up with him, you can. And if we didn't get to your question, you know, please email Brett, and y'all can continue that. It's been a great program, and I really appreciate the time that you took into putting this presentation together, sharing what you guys have learned through Raven Environmental, and joining us all today, Brett. So thanks so much.
Yeah, no, thank you, David. It's a pleasure to get to share our experience. So yeah, thank you for letting me come and talk.
All right, well, it's a pleasure. Thank you everybody who joined us, and we hope you have a good afternoon, and will join us next time.